This is the third video or third step of factoring polynomials. If you're on this video, you should have a firm grasp of how to factor out a greatest common factor and how to factor a polynomial with four terms by grouping the first two and the last two together. What we're going to do with this is, very similar to the second video. We're going to take our trinomials, which is a three-term polynomial, and make them into a polynomial with four terms, and that way we know what to do from there. This is the main part of factoring. If people are talking about factoring, usually they're talking about factoring trinomials because these have a lot of applications when we're talking about quadratics, and most of the trinomials we're going to be factoring are quadratics. There are several different ways to factor trinomials, but I feel the easiest to understand is something called the A times C method. So firstly, we have to know what A and C are. So every trinomial that is a quadratic, and a quadratic just means that there is a term that has a squared, an x squared in it. So every trinomial that is a quadratic can be written in the form of ax squared plus bx plus c, where a, b, and c are just some real number. You notice that we are in descending order, okay, and that's very, very important. The A times C method does not work if you have this rearranged. You have to have the coefficient of the squared term and the constant term also. We're going to deal with the b, the middle term here as we go. So, for instance, in the trinomial x squared minus 3x plus 5, our a would be 1, our b would be negative 3, and our c would be 5. And it is very important to recognize negative values. They will come into play in this. So for the first couple examples, I'm going to really take it slow and really work through each step. I'm going to write out the steps. They're not very complicated, but for the first couple times you might get a little confused, so you might want to write them down so that when you're doing some example problems you'll be able to figure out exactly where you're at. Make sure that your trinomial is in descending order. That way you know what the a and what the c are. So in this problem, our a is 1 and our c is 15. So once you identify what they are, you're going to multiply them together. So you have 1 times 15, and that equals 15. Next, we're going to think of factors of our new number, and again, in this case, it's 15, this number that we just created. Factors that can either be added together or subtracted together to give us a b value, in this case, positive 8. So factoring should be a pretty active process. Sometimes you're going to be able to see right away what the factors are that you're trying to use. Other times you may not. The bigger the number that you create is, the more factors there could possibly be, and you might have to list them all out to find the ones that you're looking for. So in this case, we have this first set of factors, 1 times 15, and then another set of numbers would be, another set of factors that would give us 15 would be 3 times 5. Now these are the only sets of factors, so if this trinomial is factorable, one of these sets will be able to combine in some way to give us positive 8. Okay, and this would be the group. So we have 3 times 5 gives us the 15, and it also adds together to give us the 8. Now what we're going to do is rewrite our trinomial, and we're going to, the only value that's going to change is our middle term here. The whole idea is that we are creating something that we're already used to factoring. So if we can create something that has four terms, then we can just group the first two terms and the second two terms, factor out the greatest common factor, and move on from there. So we got the 3 times 5 by multiplying 1 times 15 and thinking of the factors of 15 that would combine to give us 8. So I'm going to rewrite this as x squared plus 3x plus 5x plus 15. Okay, we didn't change the value of our trinomial. We just rewrote 8x as 3x plus 5x. And the only way we knew that that was the way we wanted to rewrite it was to find out the number 15 and rewrite it that way. Now, this is just something that you learned on the previous video. We have 4 terms. We're going to group them 2 and 2 and see if we are able to factor out a greatest common factor out of each of these sets of terms. We can take an x out of this first one. So we have an x. We're left with x plus 3. Out of this second group, we can take a 5 out. So plus 5, very important that you write a either an addition or subtraction sign depending on what you're factoring out of this. It's very important. And we're left with an x plus 3. Now we have 2 terms. There's an x plus 3 in both of them. So we can factor that out front, x plus 3 and x plus 5. Okay, and again, factoring is something that you should be able to check. If you go through and refoil all of this, you should be able to come up with your original trinomial. So we're going to do a couple more examples. Hopefully it will drive home the point. One thing to notice is that on this first part, all of the examples that I'm going to do, A is going to be 1. Now if you're really watching and you got a firm grasp of what you're doing, you're going to hopefully see a shortcut on how to factor trinomials when A is 1. If you don't notice it, it's no big deal because this method, A times C, will work no matter what. If a trinomial has the A value of 1 or anything else, if you always follow the A times C, then you're going to be in a very good place. So again, the first thing to do is figure out what your A is, which is 1, and what your C is, which is 8. Okay, we're going to, off to the side somewhere, we're going to multiply these two together. 1 times 8 gives us 8. And now we're going to think of the factors of 8, looking for the set that gives us 9. So we have 1 times 8 is 8, and 2 times 4 is 8. Okay? Now you don't have to list them all out. On these first couple examples, I'm going to list them all out, and then we're going to go through and figure out which one it is. But you're just looking for the group that combined to give you the B value. Again, in this case, it's 9. So we could have stopped right away because 1 and 8 will add to give us 9. 2 and 4, we can't do it. So we're not going to use these at all. We're just going to use the 1 and the 8. So we're going to rewrite our trinomial as a polynomial with 4 terms. So we're going to say x squared plus x plus 8x plus 8. Now people wonder, does it matter which of these you write first? And the answer is no. As long as these 2 terms combine to give you the middle term, then you're going to always be in a good place. If it's a factorable trinomial, it doesn't matter which of these terms you write first, you'll still be able to factor it. Another thing to keep in mind is that while you're factoring, it's a good idea to get in the habit of always checking the step above to make sure that what you're looking at right now, in this case here in the blue, can somehow be combined to give us our step above. And if you do that, if you get in the habit of just checking every time, then you'll always know what you're doing and what you're looking at. Right? 1x plus 8x is 9x, and nothing's changed. So now we're going to group the first 2 and the second 2 and see if there's anything we can factor out of them. And in fact there is. We're going to take an x out of this first group. and we're left with x plus 1. Now make sure that you are checking every time. This number, when you're left with a 1, is often a place where people make mistakes because they don't think anything's there. Okay, and that's why it's a good good habit to get into, to check, to make sure what you're working on, you know, the step that you're on, can somehow get back to this step, right? If we distributed the x to both of these, x times x is x squared, and the only way we can get this x is doing x times 1, which is x. So be very careful. All right, on this second group, we're going to be able to take out a positive 8, and we're left with x plus 1 again. Right, now we have the two terms, and they both have an x plus 1 in them, so we're going to factor that out front, and we're left with x plus 8. Okay, here's another quadratic that we're going to factor, and just like every single time you factor something, you should always be checking to see if there is a greatest common factor. Okay, there is no greatest common factor for these three terms. We got three terms, so we're going to do the a times c method. In this case, a is 1 and c is 20. So we multiply those together to get 20, and then we think of factors of 20, hoping that we can somehow get 9, negative 9. So we got 1 and 20 and 4 and 5, and those are our only sets. So, you know, again, it's very important to be identifying whether you're dealing with a positive or a negative. We have a negative 9 here, so there is a way that we can use 4 and 5, as long as they are both negatives, to combine to give us negative 9. So we're going to rewrite this trinomial as y squared minus 4y minus 5y plus 20. Anytime you have a problem involving negatives, you gotta just watch out what you're doing. We're going to group the first two and the second two together. The first two, we're able to take a y out, and we're left with y minus 4. Okay, notice that this is a positive y here, so after we're done factoring this step out, we better have a positive y over here. Now the only way that's going to happen is if we take a negative 5 out of both of these, and again, just be careful when you're dealing with negatives. We're going to take a negative 5 out, and we're going to be left with y minus 4. And again, it's a good idea to just check. You know, if we distributed y to y, we'd have y squared. Y to negative 4, we'd have negative 4y. If we distribute negative 5 to y, we'd have negative 5y. And negative 5 to negative 4 would give us positive 20. Again, very important to keep your eye out when you're dealing with negatives. Now we're just going to take the y minus 4 out of both terms, and we're left with y minus 5. Again, if we FOILed this and simplified, we better get what we started with. Okay, in this example, it's slightly different, but you should be going through your steps, right? Can we take a greatest common factor out of all of these? And in fact, on this one, we can. That would be an x. So now we're just going to take an x out. We're left with x squared minus x minus 30. Okay? While you're doing this problem, don't forget about this x that we took out at the very beginning. We're going to hold on to that because you have to remember, when you're factoring, the answer that you get better be able to completely multiply back and give us our original expression. We're only going to be concentrating on the stuff inside the parentheses right now. And we're going to do the a times c method again. A is 1, c is negative 30. So, and it is a good idea to keep an eye on the negative sign. So 1 times negative 30 is negative 30. Now this is nice to know, you know, the negative is anyway, because what this is telling us is that one of our factors is going to be positive and one of them is going to be negative, because that's the only way you can get to a negative answer. So I'm just going to list out all of them. Maybe you already know which factors of negative 30 will combine to give us negative 1, but let's just roll through some of them. right? We have 1 times negative 30, and I'm not going to work with the negative sign quite yet, but you could also have 2 times 15, or 3 times 10, or 5 times 6. Okay, that's all the factors of 30. Now remember, we would be using either a negative 15 and a positive 2, or a negative 2 and a positive 15, if we were going to use this group. But, this would only give us either a positive or negative 17, or a positive or negative 13, so we're not going to use that one. Okay, we could move on to the next one down, either a negative 3 and a positive 10, or a negative 10 and a positive 3. But that would either give us a positive or negative 13, or a positive or negative 7. Neither of those are negative 1, so we're not going to use that one either. Now we can use this next group, and you just have to make sure that you set it up the right way. We're going to use a positive 5 and a negative 6, because a positive 5 plus negative 6 will give us negative 1. That's what we're looking for. Again, don't forget about the x that you factored out originally. And we're going to rewrite this trinomial as x squared minus 6x plus 5x minus 30. Okay, so now we're just going to group the first two together and the second two and see what we can take out. Again, don't forget about the x that we factored out originally. We can take just an x out of this first group, so it's going to be x times x minus 6. We're going to factor a positive 5 out of this group, so make sure you write plus 5, and we'll be left with x minus 6. Okay, the next step would be to factor out the x minus 6 out of both of them. Again, don't forget about the x we originally factored out. So we have the x minus 6, and we're left with an x plus 5. Again, make sure that you can FOIL this all the way back, FOIL and distribute to get the original polynomial. Okay, here's another example of a trinomial we're going to work through, see what happens here. So we're going to do a times c, which is 1 times negative 7, and get negative 7. Now we're going to think, and again, the negative is nice because that tells us one of our factors has to be positive, one has to be negative. Now we're going to think through the factors of 7 and see if we can come up with a group that combine to give us negative 1. Okay, 7 is a prime number, so this is actually the only group that we can use. There is no way that we can combine 1 and negative 7 to give us negative 1. Since we did a times c, thought of those factors, and none of those factors can combine to give us this middle term, then this trinomial is non-factorable, and you would call it a prime trinomial. So here's an example of another trinomial, another quadratic that we're going to try and factor. And I can't say it enough. Make sure you're checking every time to see if there is a greatest common factor you can factor out, because your life will be much easier if you can do that. You should notice that a 2 can come out of every one of these. So we're going to write the 2, and we're going to write whatever is left over, x squared plus 17x minus 110. Again, don't forget about this 2. It better show up down in our answer so that when we check to multiply everything, all of our factors together, we get the original trinomial. We're only looking at the inside of the parentheses now, and you're going to see that a is 1 and c is negative 110. So we're going to go find our group of factors that combine to give us positive 17. The negative is nice to know about again, because we know that one of our factors is going to be negative and one's going to be positive. if you look over here, we have a positive 17. So that tells us that the bigger of the two factors is going to be the positive value. Now, you're welcome to list all the factors and look for them. Sometimes the bigger this number gets, the more factors there are, and that can be kind of intimidating, and you worry about whether or not you've missed one. Okay, another option is what I'm going to do this time, and I'm just going to set up a factor tree and kind of talk about how to do it that way. This is very beneficial when you're dealing with very big numbers, but a lot of people get confused the first time they see it happen. So you don't ever have to do this, but I think those of you that understand what will be said here will really make things easier on yourself. So I'm going to just set up a factor tree with 110, and that would be 2 and 55, and 5 and 11. Okay, so that means that 2 times 5 times 11 gives us 110. And that also tells us that all our factors can be found by rearranging these three factors. Okay, so for instance, we could have, and you also have to remember of the first group. Sometimes that's hard to, easy to forget about. But these two are factors also, along with this group of prime factors. Okay, so for instance, we can say that 10 times 11 gives us 110. But 10 and 11 won't combine to give us 17. Okay, we could also say that 2 times 55 gives us 110. But 2 and 55 won't combine to give us 17. And so the only other option, and this is nice and easy with three terms here, would be 2 times 11, which is 22, and 5. 22 times 5 would give us 110, and there is a way that we can get 22 and 5 to give us 17. Now remember, we're talking about a negative 110, so one of these is positive and one of them is negative. This positive 17 is telling us that the bigger factor that we're going to use is going to be the positive one. Now, if this was a little confusing, what I said here, you can always just start using, going through, checking 2 divided by 110, 3 divided by, 110 divided by 2, 110 divided by 3, 110 divided by 4, 110 divided by 5, etc., until you find all of the factors. Okay, but this might be something that you want to give a try to, especially if you're dealing with numbers that are that you're not sure what the multiplication tables for are. Okay, but we're going to rewrite this trinomial with 22 and 5, and again, don't forget about the 2. So it's 2 times x squared plus 22x minus 5x minus 110. Okay. We have, it's a good idea to check this stuff when you're working with bigger numbers like this, right? 22 minus 5 does give us positive 17, so nothing's changed. We're just rewriting it. We're going to group the first two and the second two, and we get 2 times, we're going to factor an x out of the first one. We're left with x plus 22. Again, be very careful when you're dealing with negative signs. We want to have a positive x left over so that we can match it up with these, hopefully. So we're going to end up taking a negative 5 out here. So minus 5, make sure you write that sign. X plus 22 is what's left over. Again, whenever you're dealing with negative signs, it's a good idea to check to make sure that your current step can be used to find the step above it. X times x is x squared. X times 22 is 22x. Negative 5 times x is negative 5x. Negative 5 times positive 22 is negative 110. So we're almost done here. We're going to not forget about our 2. We're going to take a x plus 22 out of both of the terms on the inside of the brackets, and we're left over with an x minus 5. Again, you can FOIL all this together, distribute everything, and we would end up getting the original polynomial. Okay, for the final example, I've come up with something that is kind of different than the other trinomials. You still want to go through the steps and say, is there a greatest common factor that I can take out of all three terms? In this case, the answer is no. So the beauty of the A times C method is that these random y's that show up don't affect us at all. It's a trinomial, so if this is a factorable trinomial, then the A times C method will work. So we're going to say A is 1, and we're going to multiply that by negative 48, and we're going to think of factors of negative 48. And again, this negative is nice because it tells us one of our factors will be positive, the other one will be negative. This negative 2 is telling us that the bigger of the two factors is going to have the negative sign with it when we rewrite it as a polynomial with 4 terms. Okay, so I'm going to come up with my factors, and I'm actually going to do it both ways. So those that are interested in the factor tree, which is a very useful tool, we'll get another example of that. Or you can just list them out. So let's start with just listing them out. So we have 1 times negative 48 is 48. We could have 2 and 24 would give us 48. We could have 3 and 16 would give us 48. You could have 4 and 12 would give us 48. Or we could have also 6 times 8, and all of these are factors of 48. Likewise, if we set up a factor tree to find the factors, we would go to 2 and 24, 2 and 12, 2 and 6, and 2 and 3. So some combination of 2 times 2 times 2 times 2 times 3 would give us 48. And we could just rearrange these factors until we found the combination that would give us negative 2. Again, if you're doing it with a factor tree, don't forget that another option would be the 1 and the 48. Okay? But this is how it would work. Let's say that this is all you had to look at, and so it could be 2 times, this gives us 8 times 3, so 2 times 24. Or maybe it would be 4 times 12. Or maybe it would be 3 times 2 times 2 times 2 times 2, which is 16. Or maybe it would be 2 times 3, which is 6, times 8. Again, this might be a little confusing right now, but the bigger this number gets, the more useful this might be. You know, when you get up to 64 or 128 and numbers like that, you're going to have a whole bunch to list out. Okay, and it can be easy to miss one. Okay, so this rearrangement might take a second, but you'll always be able to find it. But again, we're looking for the factors that combine to give us negative 2. This would only give us 22 or 26. This would only give us 19 or 13. This one would give us 8 or 16. And this one would give us either 2 or 14. And so this is the one we're looking for. Again, the hint is that, you know, one of them has to be positive, one has to be negative. And we know the bigger of the two, the 8 in this case, is going to have the negative sign. So we're going to rewrite this as x squared minus 8xy plus 6xy minus 48y squared. Again, nothing has changed. We've just rewritten the middle term. And again, the beauty of the A times C method is we're not really too concerned about these variables. So negative 8xy plus 6xy gives us negative 2xy. Now we're just going to keep going through our steps, which says to group the first two and the second two. What can we take out of the first two? Well, we can take an x out of both of these terms. So we're left with an x times x minus 8y. Now we're going to the second group and seeing what we can take out of both of these. And you notice a 6 and a y will come out of both of them. So that's what we're going to factor out, a positive 6y. We're left with x minus 8y. And again, always check to make sure that what you're looking at can be multiplied together to give you the line above it. X times x is x squared. X times negative 8y is negative 8xy. Positive 6y times x is positive 6xy. Positive 6y times negative 8y is negative 48y squared. We're in a good place. We're almost done here. Both of these terms have an x minus 8y, and we're left over with an x plus 6y. Now, again, factoring is something that you got to work on. The more you do, the easier this gets. This is going to show up all over the place coming up in the next couple chapters. There's probably 2 or 3 more chapters that we're going to deal with that if you can factor, there's nothing going to be, nothing that's going to throw you off. If you can't factor, you're always going to be struggling with this step. So this was about as hard of a polynomial as we're going to get with a being 1. The next video is going to be where a is other numbers. But again, if you're just sticking with the a times c method, nothing's going to be too big a deal.